Okay, you want to work on the labs this week, since next week's going to be busy with the tests, and then we'll work on finishing up the lab reports.
So let's take a look at chapter 14 homework. Compare the volumes of 1 times 10 to the 23rd hydrogen molecules and 1 times 10 to the 23rd oxygen molecules. What can we say about the volume? The volume is going to be the same. The volume depends on how many molecules we have. The weight is going to be different though. The nitrogen molecules and oxygen molecules weight, or hydrogen and oxygen weigh different amounts. So the volume is the same. How about 2? If we double the number of molecules, we need to double the volume. And so that's what we can say about that. The volume is going to be the same. This is Avogadro's. Which of the following gas samples would have the largest volume? If all gas samples are at the same temperature and pressure, so 263 grams of xenon, we got to figure out which one has the largest number of moles. And then we can determine, like xenon. If we look at the molar mass of xenon, it's 131.29. So A, we got to figure out how many moles that is, or molecules. Either moles or molecules. It's just easier, moles. So 263 divided by the molar mass of 131.29. 263, 131. Oh, it's close to. We probably could do this in our heads. 2 moles. So A is 2 moles. The largest, so C is bigger. So 4 moles is the biggest. That's 2 moles. 5 times 10 to the 23rd. 5 times 10 to the 23rd, how many moles is that? Less than 1 mole, because 6.022 times 10 to the 23rd is 1 mole. So that's less than 1. So C would be it. 4 moles is going to have the biggest volume. It's not going to weigh the most, but it's going to have the biggest volume because it's got the most molecules. It just depends on how many molecules we have, not how much it weighs. Individual molecules don't weigh that much. Find the pressure and torr produced by 0.0888 moles of carbon dioxide in 5-liter vessel at 36 degrees C. So here, they want the pressure. The pressure is equal to nRT over V. And so we need the moles. We got that. We need the temperature. We got that. We just got to change the temperature from Celsius to Kelvin. And we have V in liters, that's right. And then this is going to give us the pressure in atmospheres, and then we have to change it from atmospheres to torr, what they want. Let's see their answer here. Except, they use this R value. I don't use this because I don't want to memorize too many R values. And so they didn't have to do the change. We would have to do the change. And so the way I would have solved this is like this. I would have done 0.0888 moles, and then I would have used the R value I have memorized, 0.08206 liters times atmosphere per mole times Kelvin. And then the temperature has to be changed. 36 plus 273 is 309 Kelvin. Divided by the V, which is 5.00 liters. And so the liters cancel, the moles cancel, the Kelvin cancels. That gives us the pressure at atmospheres. And so they want it in torr, so there's 760 torr. So I'm going to just convert it one more step here. 760 torr per atmosphere. And so the atmospheres cancel. That gives us the torr. That should give us 342 torr. A 0.917 mole sample of hydrogen gas at a temperature of 25 degrees C is occupied by a volume. So this is the same thing. We calculate the pressure. 5, the pressure exerted by 6.04. So they give us moles, N, they give us T, temperature, and they give us P, pressure. So the only thing that's missing is the volume. So we just solve it. Volume is equal to nRT over P. We'll just plug in the moles. Temperature we have to convert. Atmospheres we don't have to convert. So they have it here. One thing they did was they rounded R. They rounded it from 0.08206 to 0.08221. So they rounded it to 3 sig figs. We aren't going to round it. We're just going to use 0.08206 always. And so we just memorize this R value and then convert everything else to it. Okay, this is 6 is a mirror problem, just figuring out the volume. 7, a 784 milliliter hydrogen lecture bottle is left with the valve slightly open. Assuming no air has mixed with the hydrogen, how many moles of hydrogen are left in the bottle after the pressure has become equal to atmospheric pressure of 752 torr at a temperature of 22 degrees C? And so what do we have? Well, we just list what we have here. We have volume, which is 784 milliliters. So we're going to have to convert that to liters, 0.784 liters. And then we have, what else do we have? We have the pressure. Pressure is 752 torr, which I'm going to convert to atmospheres. 1 atmosphere is 760 torr. I'll just convert it here. I can convert it in the equation itself, or I can convert it before. Just convert it before. So 752 divided by 760 is 0.9894 atmospheres. 0.9894 atmospheres. The only disadvantage of converting it now rather than in the equation is round off error. The temperature is 22 degrees C, which is plus 273. It's going to be 295 Kelvin. And so I just need to solve for, what are they asking for? How many moles? So they just want the moles. Well, the moles is equal to PV over RT. So we'll just plug in the pressure. Actually, I probably already did this. Let's take a look. I did the conversion. They aren't doing any conversion because they're using this different R value. So I'm not using. So I converted it to atmospheres, and we're using the R value for milliliters to liters. Do that conversion. Let me calculate the moles. So we can plug that in. We plug that in, it comes out to 0.0320 moles. Okay, 8 is a similar problem. They're just asking for the number of moles, except they give us now atmospheres. So we don't have to do the conversion. Atmospheres, they give us Celsius, we have to convert that to Kelvin. They give us liters, we don't have to convert that. Let's just use it as is. 9, at what temperature degrees C will 0.810 moles of chlorine in a 15.7 liter vessel exert a pressure of 756 torr? Alright, so looking at number 9, N is still 0.810 moles. That's okay. V is 15.7 liters. That's okay. P is 756 torr. We're going to change that to atmosphere. And then we're good. Then we just plug it in. We're going to solve for T. However, when we solve for T, the temperature is going to come out in what units? So we solve for T by plugging it into the equation, PV over NR, and we get the temperature in Kelvin. Since we get the temperature in Kelvin, this should be equals. It's 235 Kelvin. We have to convert it into Celsius. To convert Kelvin into Celsius, rather than adding 273, we subtract 273 and we get minus 38 degrees C. So this is calculation number 2, conversion from Kelvin to Celsius. Since the temperature, because of our R value, is going to give us Kelvin. All right, number 10 is the same type of problem, exact same. We have number 10, 0.142 moles, okay. 834 milliliters, so we'll have to convert that to liters. 4.83 atmospheres, we can leave that alone. And then what is the temperature? The temperature we're going to calculate is going to be in Kelvin, and then we have to convert it from Kelvin into Celsius. Okay, let's go on to number 11. How many moles of carbon monoxide must be placed in a 40.0 liter tank to develop a pressure of 965 torr, 18 degrees C? Wow, all the problems are in torr here. And so maybe it's more useful to know R in torr, 62.4, but depends on the author of the book, really. And so here, what I do is volume, 40.0 liters. Pressure, 965 torr. And then we're going to convert it to atmospheres, 760 torr per atmosphere. And the temperature, 18 degrees C. And we're going to convert it to Kelvin. And then we'll just plug it into our equation. N is equal to PV over RT. R is 0.0826. See what they got here. A sample of neon gas collected at a pressure 0.946 atmospheres. Okay, so we don't have to do anything with that. That's the pressure. Temperature is 276 Kelvin. That's good too. We don't have to do anything with that. Volume 712 milliliters. We have to convert the volume into what? To liters. How many moles of neon gas are in the samples? Just calculate that. All right. So find the volume of 0.621 moles of helium at minus 32 degrees C and 0.771 atmosphere. So again, this is just one unknown, 3 givens. We just got to make sure we have the right units. So these are just making sure the units are correct. So moles is good. Celsius we convert to Kelvin. Atmospheres is good. Volume is equal to nRT over P. A sample of neon gas collected at a pressure of 531 millimeters of mercury. So we're going to have to convert this into atmospheres. 531 millimeters of mercury, the conversion is 1 atmosphere is equivalent to 760 millimeters of mercury. And the temperature of 291 Kelvin, that's good, we don't have to convert that, has a mass of 10.2 grams. So we're going to have to convert from grams into moles using the molar mass of neon. Then we can plug it in here. And so just the STP density of an unknown gas is found to be 2.32 grams per liter. What is the molar mass of the gas? All right, so here we have to remember what the molar mass equation is. What was the molar mass equation? Actually, why don't you give this a go here? Let's see. You get